Now, for this demonstration, what we're going to do, we're going to build an organic intelligence inverter and demonstrate it. Look at it. So the first thing that we're going to do is actually in 3 steps. So as you can see on the slides, that the organic intelligence inverter, we have to do a transformation. Now, as I discussed earlier, we take the base units, which is the fractal itself, and we construct higher level geometries from the fractal to create the actual functionality that we're looking for. So in this particular case, I took 3 organic intelligence base units, as you can see on the slide, and then I combined them and transformed them into 2 higher level organic intelligence geometries or patterns. Now those patterns are actually on this unit right here on the board. So here it is right here. So here's the board that we actually made, and as you can see, those 3 patterns, we transformed them into this pattern, right? And it is this pattern that you see on the screen that is manufactured in this board. So from the 2 higher level organic intelligence geometries, we have to transform them into 1 single geometry. So basically, we have 2 different boards, and each one of them have the same higher level organic intelligence that was combined and made from step number 1. And step number 2 basically means that we have to combine them into 1. Now, in order for us to combine them into 1, as you can see on the slide, we have to connect them, right? So here we have a regular coax wire. So what I'm going to do, I'm going to connect one of the higher level geometry to the other. So that's what I'm doing now. So basically, what you see as the red wire, that is actually what I'm adding now. Okay, so they're connected, and then I have to connect an input. So I'm going to use channel 1 for the function generator as my input. And as you can see on the slide, there is an unused output, or you can say an unused portion that is not used, is not required. But of course, when we manufacture this, we won't have the unused one there. It's just, in this particular case, it's unused. And then what we'll have is now a reference clock. And the reference clock has the same purpose, it's like a bias. It has the same purpose as a pull-up resistor. Anyone who's familiar with creating electronic circuits, you have to have a pull-up resistor if you want to maintain a certain bias. And the pull-up resistor is actually needed, or in this case, this bias clock is needed because the inverter has a rule where that when the input is 0, the output must be 1. So this bias clock serves as that. It provides the output when there's no input. And then what we'll do, we'll take the output of the inverter and connect it to the scope. Okay, so I'm basically connecting the physical board as what you see here in the slide. Right. So now I've done the physical connections. So everything I have on the bench matches exactly what you see in the slide. So now let's get to the truth table. So let's go back and adjust our logic levels. Actually, right now it's set to 147 megs at 100 millivolts peak to peak. So let's just use that case. So channel 1 is on, and channel 1 is the input, and channel 2 is the bias. So if there's an input, then that means the output must be 0. And if you look at the output of the scope, the output is 12 millivolts. So that is exactly correct. So we are getting an input, which is 147 megahertz, at 100 millivolts peak to peak, and the output is 147 megahertz at 12 millivolts peak to peak. So that satisfies the case of the inverter where you have an input and you'll get 0 on the output. So now what we'll do, we'll turn off the input. And when we turn off the input, now we should get a logical 1, which in this case we get 79.8 millivolts peak to peak, which is a logic 1. So as you can see with the inverter, when the input is not present, you get the output. As you can see there, we're getting 80 millivolts peak to peak. But when the input is present, you can see the output, I have to hit the phasor line, of course. We get 12.8 millivolts, which is a logic low. So the truth table holds true. So now let's go back and put our amplitude of the signal to 1 volt peak to peak. Let's see, so 1 volt peak to peak, channel 1, channel 2, 1 volt peak to peak. I'm going to adjust the scope back to the voltage per division to 200 millivolts peak to peak. And as you can see, both channel 1 and channel, both the input is on. So if the input is on, you should get a low on the output, and of course we get 120 millivolts on the output. And now remember, I just changed the input voltage range or the amplitude to 1 volt. So now we're basically we're getting 112 millivolts peak to peak on the output, which is a 0. If I was to turn off the inputs, 0, and then you see we get a 784 millivolts peak to peak on the output. So that's the N, that's the inverter, or what we will call a NOT gate. So as you can see, again, the inverter has the same functionality in terms of the AND gate and the OR gate. They don't require any external power. The actual processing is being done in the spiritual dimensions, and the OR gate and the inverter and the OR gate, they're actually being used as a bridge to connect the energy from this physical world into the spiritual world and back. So it's like the middleman.